Is it on my side that I cannot see yours? I'm only seeing names of people. Did you share your
Yes.
screen?
It says let everyone know they are being recorded. I haven't started sharing the screen. I just need so that's I think we're doing 4.5 today. Okay. I'm used to recording now. Share the entire screen. Are you able to see now?
Yes, ma'am.
Yes.
Yes, ma'am. Can you increase the volume, please?
Can you hear me now?
No.
I can hear you.
I think it might be on your side because I've increased it. Because I've increased the volume on my side. Can you see the screen, guys?
Yes, ma'am.
Yes, we can.
Yes,
Yes,
ma'am,
ma'am.
we can see.
Thank you. So we're
Yes.
still on exponential and logarithmic functions, exponential and logarithmic equations. Okay. So now the objective is that we able to solve exponential equations, logarithmic equations, and compound interest. Now let's go to exponential equations. They say an exponential equation is one in which the variable occurs in the exponent. Is that clear, guys? Yes, no?
Yes, ma'am, it is.
Okay. Now they say some exponential equation can be solved by using the fact that exponential functions are one-to-one. This means that if you have a to the power of x and y equals to y to the power of x, this means that x is equals to y. Is that clear or not?
Clear.
It is, ma'am.
Clear.
Yes, ma'am.
Now they say the following guidelines describe the process for solving an exponential equation. So now these are the guidelines that we need to look at. Let's see. So it says guidelines for solving exponential equation. Isolate the exponential expression on one side of the equation. Take the logarithm of each side, then use the laws of logarithms to bring down the exponent. Then solve for the variable x. Are the steps, are the guidelines clear? Yes, no?
Yes, ma'am.
I need 3
Clear.
yeses.
Clear.
The clear, ma'am. Yes.
Okay. So now let's go straight to the example using those guidelines. They say consider the exponential equation. So this is the exponential equation that they want us to consider. And they say, okay, find the exact solution of the equation expressed in terms of a logarithms. So then you have 3 to the power of x plus 2 is equals to 7. Now the first guideline says isolate the exponential expression on one side of the equation. Lucky us, this is already there. But if it was something like this, for example, you have 3x plus 2 minus 7 equals to 0. What do they mean by step 1 is that you take everything that has an exponent to the left. In this case, it's this term. So then you have 3x plus 2 and everything else to the right. That's what the first term says. Isolate the exponential expression on one side of the equation. Are we all together there?
Yes, ma'am.
Yes.
Okay,
Yes, ma'am.
so now let's go back to this one. So we have a is equals to 3 to the power of x plus 2, which is equals to 7. Now the second step says take the logarithm of each side, then use the laws of logarithm to bring down the exponents. Now, normally when they say take the logarithmic, they mean the common log. Do you remember the common log from the recordings?
Yes, ma'am.
Yes, ma'am.
It's a log of
Yes, ma'am.
base 1.
Of the 10.
Log
Thank
It's
you.
of base
log of
10.
10.
Thank you. So if I write log of x, this means it's log of x base 10. So when they say take the logarithm, meaning that they want you to take log of 3 to the power of x plus 2 is equals to log of 7. Right? So now, then they come back and say that, okay, let's go back. It says take the logarithm of each side, then use the laws of logarithm. Do you remember the laws of logarithm?
Yes, ma'am.
Yes, ma'am.
Okay, Just to highlight them, the first one says if you have log of a, okay, let me not just highlight them. Let me just check if I have them. Because if I'm writing, if we write, then it will take us time. Here, these are the laws, logarithmic laws. Do you remember these ones? They're section 4.3. Let's see. 4.4 actually. Section 4.4, meaning the previous video. These are the laws of logarithms that you need to make sure you understand them and you know them by heart, because in this module, you don't get a cheat sheet. Are you okay with these logarithmic laws?
Yes, ma'am.
Yes, ma'am. Yes.
So meaning
Yes,
that
ma'am.
number 3 is what we're looking for, because we have an exponent, right? Since we have an exponent, it says if we have log of a to the power of c base a, then you take the exponent and write times it by log of a base a. So now when we come to solving that particular example, it means that we'll use the laws of logarithm number 3. So now let's go back to, where is it? This example here. So let me just write it here. So this is 3x plus 2. Okay, this is 3x plus 2 is equals to 7. They say we take log both sides, so it's 3x plus 2 is equals to log of 7. Now, as we said, we use the third law, so we take this exponent to the side. So this becomes x plus 2. Now put everything in brackets, because this is x plus 2, and then you don't want to end up writing, for example, x plus 2 log of 3. So I put everything in brackets. So now this is log of 3 is equals to log of 7. Now, because we are solving for x, we then want to take this part over here and divide. So we want to divide by this part, remove this part first. So what we can do is, so this is log, we can then say log of 3 divided by log of 3. So log of 3, divide both sides. Then we're left with x plus 2 is equals to log of 7 over log of 3. Now, because we are looking for x and not x plus 2, so meaning that we have to take the 2 to the side. So then this becomes x is equals to log of 7 over log of 3 minus 2. Are we together there, guys?
Yes, ma'am.
Yes, ma'am. Yes,
Okay,
ma'am.
thank you. Now, I just want to highlight something. Do you see how I don't say, okay, fine, find the value. I don't say x is equals to maybe 0, something, something. So this means that in the exam, if I give you something like this and I say solve, this is where you're going to end, because you're not allowed to use a calculator. Are we all together?
Yes, ma'am.
Yes, ma'am.
Did I confuse anyone on this particular question?
Okay. So, ma'am, you said exam is gonna be multiple choice, right?
Yes.
So this, okay, just for argument's sake. So log 7 over log 3. Somebody's mic is making echoes. So I can say log 7 minus log 3 parenthesis minus 2. Will I be still correct?
It will depend on what I gave you.
Okay.
So I can give you something like this. This is maybe, let's say, option 1. And I know some of you will make a mistake and say, I'll say, okay, log of what? Of 7, I mean of 3 over log of 7, because I know someone will make a mistake, isn't it? Minus 2. And then the third option, I can give you x is equals to log of 7 over log of 3. I know someone can forget to say minus 2 and they'll say plus 2. Do you see that? Or
Yes.
I can say, okay, fine. For example, number 4, I can say x is equals to log of, what's this? Log of 7 plus log of 3 minus 2. And someone can say, oh, this looks like it. But remember, when you are dividing, this has to be negative. Do you see that? So it's
Yes.
those mistakes that people are doing that will cost them. Because if you look at it, all of them, they are close to the solution.
I see.
So that's why you need to be very careful.
Okay, thank you, ma'am.
Thank you. So can I ask something? I think maybe because I asked too much questions. I was one of those students. Now, if you look at what I just currently did here, what is not making sense from what you have learned in previous years? Let's say that. What is not making sense? Especially when solving this. What is not making sense? Guys?
I can say where you wrote x plus 2 into brackets log 3. Why didn't you remove the brackets and then we have x log 3 plus 2 log 3?
So you can do that. You can, so what you mean is, okay, let me just go back here. So you mean that instead I should have just multiplied?
Yes.
The reason why I didn't multiply, because you can do that, but the reason why I didn't multiply, so you mean log of 3 like this is equals to log of 7. So you are saying, why didn't I say x log of 3 plus 2 log of 3 like this?
Yes.
Is equals to log of 7. The reason why I didn't do that, because then for me it's easier to just divide by what here? Divide by log of 3 to actually cancel this term out. Do you see that?
Yes.
And then after that, I just divide both sides by that, and then it becomes easier for me. Because otherwise from here, let's see, what do we have? We have x log of 3. This is equals to log of 7 minus 2 log of 3. And then you have to apply the property here. Do you see that? There's a property.
Yes.
Oh, no. Instead of applying the property before, then you still have to divide by log of 3. Do you see that? So you then have to divide by log of 3, divide by log of 3, divide by log of 3. So then it means here you remain with x is equal to log of 7 over log of 3. This log 3 and this log 3, they form a 1, so this is minus 2. Do you see that you're actually adding an extra step to it, but it still gets you the answer that we got?
Yeah, I see it.
Now I'm giving you 2 seconds. I want you to discuss something because I want to check a question related to the question I want to ask myself, the one I want you guys to ask me. So discuss that question. I know you might not know it, but look at what we did. We had 3 to the power of x plus 2 is equals to 7. Go back to exponential functions in grade 10. Were you doing that? Where you introduce the log? Guys?
Sorry, ma'am, come again.
I'm saying that here, this question is asking us to solve. We had 3x plus 2 is equals to 7, right? And in grade 10, we didn't introduce a log. Do you remember that?
I think they were doing K substitution. I didn't do my matric in this country, so yeah.
Oh, okay. So now, those who remember it, can you remember that we didn't do log in grade 10? I don't know if you remember.
I forgot.
We don't remember.
Were you doing like maybe saying like 8 and 4, then you raise them to the same powers, same base, they have same base, then you equate
Yes.
the exponential?
Yes. So for example, what let me remind those who didn't remember. For example, let's say you had 2 to the power of x plus 2, right? And you had is equals to 35, for example. Ne? We didn't use the logs. What we did, we said, okay, fine, 35, because I already know the base is 2 here. What is 2 to the power of something? What is that something that can give me 35? 2 to the power of what will give me 35? Guys? 2 to the power of what will give me 35?
I don't think it is 2 because 2 to the
doesn't
power
have.
5 is 32. Then I don't think there is any number that
sorry.
is to the power 30. Yeah, so, and let's say 32.
wanted 32. I wanted 32, sorry. So what is to the power of 2 to the power of something that gives me 35? You say 2 to the power of 5, right?
Yes, ma'am.
Yes.
So then
Okay.
we said this is 2x plus 2 is equal to 2 to the power of 5. Now we said, okay, because these bases are the same, and we also reply to what we have learned currently is that if a function is 1 to 1, therefore we can be able, this part over here, this part over here, where we say if a is to the power of x and equals to y to the power of x, then x is equals to y. And we also learned from our exponential function in grade 10 that because this is a base of 2 and this is a base of 2, meaning these part has to be equal. So then this is x plus 2 is equals to 5. Do you see that? Therefore, then we said x is equals to 5 minus 2, then x is equals to 3. Are we all together there? That's how we used to do it in grade 10, isn't it?
Yes, ma'am.
Yes. Now, okay, someone might raise a point of saying that, okay, let me be that someone. I'm raising a point of saying that, ma'am, you are saying now that I have 3 to the power of x plus 2 is equals to 7. Now you are making me take the log. So why is that so? The reason being that is because if you look at this number here, there's no number, there's no way you can raise 3 to the power of something to get 7. Does it make sense?
No, ma'am.
I'm saying that, for example, so in grade 10, this is what we were doing. Grade 10, 11, 12, our exponentials. This is what we were doing, isn't it?
Yes, ma'am.
So it was easy for us because we knew that we can raise whatever is on the right hand side to the power of whatever base is on the left hand side to get that value. So meaning that we knew that we can do what we are doing here on this step here. We will say 2 to the power of x plus 2 is equals to 2 to the power of 5. Are we all together there?
Yes.
Ma'am.
Now,
Yes, ma'am.
now when I started trying to explain this, in our problem, for example, we have, okay, no, let's do again. 2 to the power of x plus 2 is equals to 35. What did you say about this one? You said you can't raise because there's no number you can raise to the power of, 2 to the power of such that you get 35, isn't it?
Yes, ma'am.
So it
Yes,
means
ma'am.
that the logarithms, they actually help us to actually solve a problem like this, where you can't even raise this power to the power, where you can't say 2 to the power of something to get this number. Do you see the importance of the logarithm?
Yes, ma'am.
Yes.
Yes.
Yes, ma'am.
Now, it doesn't necessarily mean that you can only apply to such problems. You can also apply to the problems that you were doing in grade 10, such that you were able to raise this to the 2 to the power of something to get that 32. And let me just explain that part. So for example, if you have 2 to the power of x to the power of 2, so there are two methods of doing it. 2 to the power of x plus 2 is equals to 32. We said this is 2 to the power of x plus 2. This is equals to 2 to the power of 5. Now we then say, okay, fine, these are then equal. So it's x plus 2 is equals to 5. And therefore x is equals to 5 minus 3. Therefore x is equals, minus 2. Therefore x is equals to 3. Now, the second method is the one that we are currently learning. Now, that one helps because even if we don't know how to raise this power, this 32, the number on the right-hand side to the power of something, so such that the bases are the same, and then we can only equate the exponents. Logarithm helps us to do that. But we can also use it for such a problem because we know that 2 to the power of x plus 2, right, is equals to 32. And then we can say this is 2 to the power of x plus 2. This is equals to 2 to the power of 5. Then we can take log on both sides. So this is 2 to the power of x plus 2, like this. Then this is log of 2 to the power of 5. Now, because we are using the law of logarithm that says if you have log of a to the power of c, this is c log of a. So we can use that law, so meaning that this becomes x plus 2. Remember, there are two terms, so put them in brackets, and this is equals to 5 times log of 2. Now, if you divide log of 2 here, and here log of 2, you will notice that here you remain with x plus 5. X plus 2 is equals to 5, which is where we are here. So then you can simplify and say x is equals to 5 minus 2. Therefore, this is equals to 3. So meaning that if you are able to raise whatever is on the right-hand side to the power, to the power such that you have a base of 2, then rather do that because the step is more easier. But if you cannot raise, especially the right-hand side, such that the base is what? Is 2, then you can follow the logarithmic log. Then you can take the logs both sides and use the logarithmic laws to be able to solve your problem. Is that clear?
Yes.
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 Yes, ma'am.
Okay. Anyone?
Yes,
Did I
ma'am.
lose? Okay. Now, here, for example, we can't be able to say 3 to the power of something to get 7. So that is why we use the log laws. Are we together?
Yes,
Yes.
ma'am.
Yes.
So now they say
Yes.
use a calculator to find an approximation to the solution rounded to 6 decimal places. So meaning that they want us to take what did we get? We said this is x is equals to log of 7 over log of 3 minus 2. That's what we got. So they want you to put this in a calculator and see what value you get. That's what they want you to do for B. Are you all together there?
Yes, ma'am. Yes.
So
Yes,
that's
ma'am.
what we got. That's what we got. So in the exam, this is where you will end. I won't say this is equals to, I won't actually go to B. You see what we do with B? We actually approximate. So you put in the calculator, then you approximate the value. Does everyone understand this particular problem?
Yes, ma'am.
Okay. So now they want
Yes,
you to
ma'am.
check the answer. So meaning that you take the value of x, substitute it into the original, that one, which is 3x plus 2 is equals to 7. You take the value of x, you substitute it here, and you see that it's approximately 7. Now, I'll give you 2 seconds to discuss this one, and then I come back and explain it. I'm coming back. I just need 2 seconds. 2 minutes, actually. 1 minute. Yeah.
Can we start? Yeah. I think we first need to take a 6 to the right. Yes.
Yes.
And then drop it down our 2x, even 2x ln e minus x ln e equal to 6. And then we are left with 2x minus x equal to 6. And then 2x minus x x, right?
Hello?
Yeah, I think x equal to 6.
So we're introducing the natural log. Is everybody following?
Yes.
I am
Pardon,
lost.
can you repeat that?
We introduce natural log, which is ln.
Okay.
So we're going to have ln of e. I think she said it. Who was talking? But she was a little bit fast.
Fast, yes.
Oh, it's me. Was I fast?
Yes,
Yeah.
you are fast.
Oh, I'm
Can you repeat
sorry.
that again?
Yes.
Okay.
You can keep going.
Okay. Okay. I said step 1, ne,
Hmm?
we move 6 to the right, right?
Yes.
And then we are left with e to the power of 2x minus e to the power of x equal to 6, right?
Yes.
And then we introduce ln. Ln, what did you call it? You said
The natural.
ln. You said
Natural
ln.
log, yeah.
Natural
Yeah,
log.
ln. Yeah, so we're gonna say 2x ln e, like the natural log e, yeah, minus x ln e is equals to ln 6.
6.
I'm sorry, kapil kirile 6, ln 6. So we're gonna be left with 2x minus x ln 6. So our answer will be x equal to ln 6.
Okay, listen. Um,
Hmm.
natural log of e
No,
is
something is not right here.
Yes, I'm
okay.
lost.
Introduce the ln. We are going to take the exponents behind the same way we did with log 10. So we are going the e to the power of 2x is going to be ln of 2. I mean 2x ln e.
That's what
Uh,
I said.
yes.
Yeah, but your answer is not coming right. How did you end up having
Lin E. Lin
ln
6.
supposed to be ln3, isn't it?
guys.
No, actually we have a minus sign in the middle. So
Yes.
let's take it to the third step. We have
Okay, let's do
2x.
it step by step, guys.
Sorry,
ln
I
Yeah.
have the solution.
No, there's someone who was saying let's put 2x then ln e. Who was saying
Yes.
that?
Yes.
Yeah, let's start
My
from there.
Yeah,
yeah,
let's start from
that's the
there.
step I want to explain.
Yeah,
Yes,
explain.
It's
let's explain
2x.
it.
Yeah, I'm saying it's 2x ln
2x
e
lin E. Ne?
Yes.
minus
Uh,
X lin
x
E.
ln e
Yes.
equal to ln 6.
6. Okay. Another step.
Another step, actually ln e is equals to 1.
Yes.
So we are left with 2x
Minus x.
minus x equal to ln 6.
Lin
Yes.
6.
So 2x minus x, it's x, right?
Yes.
Okay.
So I'm saying my x is equal to ln 6.
Guys, just to be sure, I just want to be sure of something. There
Mhm.
is no law that can combine e to the power of 2x minus e to the x, right? Like exponential law or something.
Using the exponential law, we are going to dissolve e to the exponent of 2x to be e to the exponent of x in brackets to the exponent of 2, so that we have e to the exponent of x, and we are going to use the k method, substituting e to the exponent of x is equals to k. Then we are going to have k to the exponent of 2 minus k minus 6 equals to 0. Then we solve for k.
That's what I was thinking.
yeah,
So
because this one
we introduce K
is giving
method.
a
Yes, we
incorrect.
introduce the k method.
Can I come into the discussion? I
Yes, ma'am.
like the person who said, because I didn't check who it was. I like the person who said there is no law to combine e to the power of 2x minus e to the power of x.
I think that's what's lonely way.
Do you see that?
Then-
So meaning that I just need to clarify something. That's why I want you to discuss, because it's a question that does come into the exam. I think it's also a question in the assignment. I need to go back and check because I created assignment last year. So this is question, it's one of the questions that's in the exam. So now initially you guys said e to the power of 2x, right? Minus e to the power of x is minus 6 equals to 0, right? So you are saying e to the power of 2x minus e to the power of x is equals to 6. So you're saying I take ln both sides, right? So if you take ln both sides, e to the power of 2x minus e to the power of x is equals to ln of 6. There's nothing else you can do from here. Does it make sense?
Yes, ma'am.
There's nothing else you can do from here, but only to go back and say e to the power of 2x minus e to the power of x is equals to 6, basically. So when one person said there's no law that you can use to combine e to the power of 2x minus e to the power of 2x, they were right there. So meaning that your x is equals to ln 6 is not correct. So now you need to discuss how then we start solving this particular problem, because it's one of the problems that is there in the exam. In most, I like it. It's a question I like, by the way. Yeah. So then how do we do this?
We introduce the K method, ma'am, as I've said. We are going open bracket. We are going to have e to the exponent of x close bracket to the exponent of 2. Since the laws of exponents, we dissolve e to the exponent of 2x. I don't know if you understand me.
So you are saying this. So you are saying that I have e to the power of 2x minus e to the power of x minus 6 is equals to 0. So
Yes.
then I say e to the power of x to the power of 2.
Yes, minus
Because
e to the
according to the laws of exponent, if I have a to the power of m to the power times n, I can write this as a to the power of m brackets n, or I can write this as a to the power of n brackets m.
Yes, ma'am, that's what
Because
I'm
this is times that, right? Minus, now we can see that this is to the power of x and what am I saying? E to the power of x, this is the same as to the power of 1 minus 6 is equals to 0. 6 is equals to 0.
Yes. Then we let e to the
You
power of
see
x
that?
be k.
Thank you. So now, before we introduce the k method or the x method or whatever, by just looking at this, by just looking at this, you can see that this looks like a quadratic equation. But instead of x, it's actually what? Ex. Guys, is it clear or it's not clear?
It is clear, ma'am.
So
Yeah,
as she said, you can say let x is equals to e to the power of x, or because she said k method, let's use let k. So you say let k is equals to e to the power of x. And then you go and say e to the power of x, sorry about that. So this is equals to e. What am I doing now? Yeah, you see, long time not coming to teach with recordings. Okay, so let's say now we put k here. This becomes k squared minus k, because we say to the power of 1 to the power of 1 minus 6 is equals to 0. Then this k squared minus k minus 6 becomes the quadratic equation. Do you see that?
Yes, ma'am.
Guys?
Yes,
So
ma'am.
let's write
Yes,
it. K
ma'am.
squared minus k minus 6 is equals to 0. Now let's factor out. This is equals to 0. So this is k. Give me the factors.
I think it's great.
Minus 6 and 1.
K plus 2
Okay. Let me write it. K plus 2
and k minus 3.
minus 3. So therefore, this is k is equals to minus 2, or k is equals to 3. Are you done?
No, we are not
No,
done.
go back.
We go
Thank
back
you.
to e to the exponent of
Yes.
x.
So since we know that k is equals to e to the power of x, we need to substitute. So now we then go and say this is e to the power of x is equals to -2, or e to the power of x is equals to 3. Are we done?
No, we are
No.
not.
Oh,
So what do we do? What do we do?
We introduce ln
Where?
on the e to the exponent of x equals to 3, because the e to the exponent of x equals to -2 is undefined. We cannot find a solution for that.
Why?
There's no answer. Logs cannot give a negative. There's something about negative and logarithms.
Yes, that
The
doesn't just.
domain, the domain of a function, of a log function. Remember what we said? The domain of a log function, x can never be negative. Therefore, x is greater or equals to 0. Do you remember that one?
Yes.
Yes, that's
So
the
meaning
condition.
that,
yes, ma'am.
yes, meaning that we can't do this and say, Lynn, on the left hand side it's correct, but on the left hand side is correct, but on the right hand side we are not doing maths, because we know that the domain, whatever is inside the log function, whether it's a natural logarithmic, whatever, should be greater than 0, should be a positive number. Do you see that? Does it make sense?
Yes,
Thank
ma'am.
you. Now the other thing is that there is no number whatsoever that you can substitute here for x and get a negative number. You can choose any number, substitute into the power of x. You'll always get a positive number. That's another reason. Do you see that?
Yes, ma'am.
Yes.
Yeah, so e to the power of -5 will give you 0, or 2, but it will never give you a negative number. So therefore, this one is undefined. So meaning we'll perform ln here. So e to the power of x, this is 3, and then ln of e to the power of x. So then ln of 3. Now, just to go back to our properties, let's go back to our properties. I think it was 4.3. Yes, okay. Discharge 4.3. I opened all the slides because I need to remember which one is this. Let's go back to our property, because there we are dealing with the ln. Let's go to the natural log properties. Common log, natural log properties. There we go. So now here it says that we have, do you see here, guys, where it says number 3, where it says ln of e to the power of x is equals to x?
Yes, ma'am, we see.
Yes, thank you. So that's what we're going to do. That's what we're going to use. Okay, where was I solving? Oh, I was solving on the slides. 7.5. Where are we solving our problem? On the slide.
No, ma'am. I think you're on
You
where
discarded the page, ma'am.
did it.
Ah, okay.
You didn't save it.
It has been a while. It has
You're supposed to
been a
say keep. You
while.
say discard.
Oh, okay. Yes, ish. I see. So then it means that we'll use that law where it says ln of e to the power of x is just equals to x. So let me just write it fast. We say that this is e to the power of 2x minus e to the power of x minus 6 is equals to 0. Then we wrote e to the power of 2x. E to the power of, so e to the power of x to the power of 2 minus e to the power of x is to the power of 1 minus 6. Then we let k is equals to e to the power of x. Then this is k squared minus, minus k minus 6. I like using x normally, not k, but it's still fine. I'm lying. If you use x, it will confuse you with this x, so don't use it. Use k, thank you. So this is k minus plus 2, then k minus 3 equals to 0. Then we k is equals to minus 2, or k is equals to 3. Then we say e is equals to minus 2, or e is equals to x is equals to 3. We did explain why we're not using that. So then this is e to the power of x is equals to 3. So ln of e to the power of x is equals to, what's this? This is 3. What's this? Ln of 3. Therefore, according to this rule, so this is equals to x is equals to ln of 3. Are we all together, guys?
Yes, ma'am.
Ma'am,
Yes.
ma'am, can I have a question? I'm a bit confused. What was going to happen if we were supposed to use the log instead of the ln?
Okay, yes. Okay. Hold it right there. I'm here, right? This is what I'm there, ne?
Yes, ma'am.
Now, if you use if we go back to our properties of log, so we're saying that we have ln of e to the power of x is equals to ln of 3, right? Now, if we go back to our logarithmic properties, let me go, and I know I opened them here. Let me go back to the logarithmic properties. Where are they? Where are you? What are you? What are you? Here. Do you see these ones? These properties, can you see them, guys?
Yes, we can see them.
Yes, ma'am.
Yes.
If we go back to these properties of ours, like this, I want us to look at number 3. Do you see number 3? Can you see number 3? It
Yes,
says
ma'am.
if you have log of a to the power of x space a is equal, that's the property that I'm talking about. Okay? So now it means that if I have log of a to the power of x space a, then the answer is equals to a, right? Now, the reason why we didn't use a log here, because the powers will not cancel. For example, let me use the log that you are talking about.
Sorry, ma'am. Is it equal to a or is it equal to x?
Thank you. It's equals to x. Thank you very much. Keep. Is equals to x. So let me write it here. So if we have log of a to the power of x base a, this is equals to x. Do we agree there?
Absolutely.
So
Yes,
now we
ma'am.
are saying that our answer is e to the power of x is equals to 3, right? Now we use log instead of e, ln. Let's see what happened. And we notice that when we're solving, we're using a common logarithm, isn't it? So this is a common logarithm, meaning that this is log of e to the power of x base 10 is equals to log of 3 base 10. Are we together? There.
Yes, ma'am.
Okay, let me write it here.
Yes,
So this
ma'am.
is log of e to the power of x base 10 equals to log of 3 base 10. Is there something we can do from here? Guys?
Nothing except dropping the logo, I think.
Okay, we can do that and say this is x log of 10e is equals to log of 3 base 10. We can do that, right? Maybe if we solve using a calculator and see if we can get the same expression, because I'm seeing something different here. Can someone check if x is equals to log of 3 base 10 over log of e base 10 is the same as ln of 3? Can someone check that? Because you asked a very valid question. Can someone check that, please? Guys, I know you have calculators somewhere.
Checking, ma'am.
I want you to check if log of the common log of 3 divided by the common log of e, do you get the same answer as ln 3?
Okay.
Because I was trying to answer the question of why we are using ln instead of log, but I'm looking at the point of view where you are coming from, especially from the question. So let's see what we get. But I'm still about to explain why we use ln instead.
The answer is ln 3, ma'am.
Of this expression.
Yes.
That's what I assumed as well. So it says ln 3 straight.
Yes, it says ln of 3 straight.
So it means we can use the log, what's this? The natural log, the common log as well to solve this problem. Do you see that? Guys?
Yes, ma'am, we can see.
Yes, ma'am.
Yes, ma'am.
So the person who asked the question, do you see we can use the common log?
Yes, ma'am. I can see that, ma'am. But I was still struggling, just trying to struggle, as you are saying, I'm trying to follow. I was trying to get a calculator to see whether I get the same answer, but I'm getting there, ma'am, and I'll try to catch up, ma'am.
Okay. Now, if you look at what we have currently done here, it's a lot of steps just to tell us that we end up at ln 3. Do you see that?
Yeah, that's a lot of ways to go.
Ma'am,
You see?
is what's log E?
Log E, it's log E base 10 is what we got from here.
Log E base 10. What's log E base 10? It's just log E base 10.
Yes.
Okay.
So now, if this expression leads us to this is a long way of actually solving this particular problem. Does it make sense?
Yeah, because we have to take a logarithm of a logarithm now.
Yes. So now it means that, so I'm answering the question that was asked, why did we use ln? The reason why we used ln is because if we have e to the power of that and 3, and we know that the ln of e to the power of x is just equals to x. Why is that so? Because we know that ln of x is the same as the log of x base e. Do you see that? So that's the natural logarithm. Now, meaning that what we did here, we actually took the log base e by saying ln of e to the power of x equals to ln of 3. We are basically saying the same thing as ln of e to the power of x base e is equals to ln of 3. Are we all together there?
Yes.
Meaning, according to this.
So, ma'am,
Yes.
So does that mean ln is the shortcut of a log? A natural number is a shortcut of a logarithm.
Yes. The natural logarithm, it's actually the shortcut of saying log of base e. Remember with our exponential functions, right? We had that y is equals to ax, and they say that a should be greater than 0. Then we'll have our exponential functions. Do you see that? And if you take e in the calculator, you see it's 2 comma something something. It means that it can be used as a base as well for an exponential function. That is why there's a function called y is equals to e to the power of x. Now, what is the inverse of this exponential function? Is that one, which is y is equals to log of what? Of x base e. That's the inverse of this particular exponential function. Now, what is the shortcut? It's ln of x. So meaning that, because we know that if we take, according to the properties of the logarithms, if we say log of a to the power of x base a is equals to x. Now there's this e, there's this e, therefore your answer this side will be x is equals to ln of 3. So meaning that if you see an e to the power of something, use ln instead, because then there will be that property being applied, especially if you see e to the power of something. Then that property will be able to apply there, and it becomes easier for you to solve the problem. And then if you use the common logarithm, what happens is that you then have a long step, and then you will need a calculator to then confirm it. Are we together? And we just confirmed it that we can use both, but one then gives us a long question, and the other just helps us to then use the properties of logarithms to then apply and get the answer. Are we together or not? We're together. Okay, so now in the textbook, they said e to the power of 2x minus e to the power of x minus 6, because they know that this is the same as x, basically e to the power of x. So you know here you normally put x, and then you check. Then this is 3, this is 2, this is minus, this is plus. Then you say e to the power of x is equals to 3, or e to the power of x is equals to minus 2. Therefore, they took the ln of e to the power of x, which is equals to 3. Therefore, even if sometimes you can even drop the power according to the properties, because ln of x, e to the power of x is the same as x ln of e. And we know ln of e is just what? Is 1. So this is x. You can use that as well. So, meaning that this is x is equals to ln, x is equals to ln 3, and we define why, we mention why that is undefined. I hope we're all together and we understand that question. Are we all together on this question, right? It might or might
Yes,
not be in
ma'am.
the exam. And don't say,
Yes,
if
ma'am.
it's in the exam, don't say I didn't show you. It might or might not be in the exam. So this is how they did it in the textbook. This is the textbook. And this is a textbook. And this is a textbook. And the equation e2 leads to x is equals to ln 3. This is the textbook, but the equation e to the power of x has no solution, because e to the power of x is always greater than 0 for all values of x. And therefore, then they say that's x, ln is equals to 3. So basically, they're just showing there that is the only solution. Now let's come to logarithmic equations. Now they say logarithmic equation is one in which a logarithm of a variable occurs. It makes sense, that one as well, isn't it? Now they say that some logarithmic equations can be solved by using the facts that logarithmic functions are 1-to-1. That means this expression, if you say log of x base a is equals to log of y base a, it means that x has to be equals to y. Together. Are we in the togetherness, guys?
Forever, ma'am.
Thank you. Forever, yeah. So the following guideline describes the process for solving the logarithmic functions. I think it's the same guidelines. Let's see. Guidelines for solving logarithmic equations. Isolate the logarithmic terms on one side of the equation. You might first need to combine the logarithmic terms. But have you noticed that with this guideline, it's always one term on the left? It's like this.
Yes,
A
ma'am.
lot of terms, like for example, 3x plus 2 minus 7 is equals to 3. And then you have 3x plus 2 is equals to 7. So most of cases, it's just two terms. When they say isolate, did you notice that? Or is it only me?
We notice, ma'am.
Thank you. Write
We
the
do.
equation. So
I
they
was
say
saying,
write the, yes, I'm listening.
I was saying we noticed.
Thank you. Now they say write the equation in exponential form or write the base to each side of the equation. Now solve for the variable. Yeah, I'm telling you. Now number 2 to me is important. And I did show you how. Can someone help me? If I have y is equals to a to the power of x, how do I write it in the logarithmic form? Okay, let me not ask that. If I had y is equals to log of x base a, how do I write it in exponential form? Because they say write in the equation in exponential form. Guys, am I talking to myself?
No, ma'am.
No, we are here.
No.
I know I did that. I did mention it in one of the videos. How do I write it in exponential form? Because number 2 says write in an exponential form, meaning that you guys won't get full marks because you only understand 1. But number 2, they say write the equation in exponential form. Let's fix that problem. How do we write this? Because it's a logarithmic and want to write it in exponential form. How do you write it in exponential form?
I think it's gonna be. Okay, you can go ahead.
No, I wasn't
Oh,
talking.
I
I'm
was-
waiting for an answer.
I think someone was talking.
Yes.
I think it's gonna be a to the power of y equal to x.
Okay. Is she right or not?
She's right, ma'am.
She's right.
That's right.
Okay. Let me remind you why. She says it will be a to the power of y is equals to x. Ne? The exponential form of the logarithmic function, like this. Isn't it? Guys? That's
Yes,
what
ma'am.
she's saying.
Yes, ma'am.
Now,
Yes, ma'am.
let's highlight the relationship so that it makes sense to you. Remember we said that the exponential function y is equals to a to the power of x, right? We said the inverse of exponential function is what? Is a logarithmic function, isn't it? Do you
Yes,
remember
ma'am.
that part?
Yes.
And we said the inverse, then we can write it as y is equals to log of x base a. That's what we said, right? That's the inverse. But when we are finding the inverse, what do we do to the exponential function? We interchange x and y, then becomes. Do you see that?
Mhm.
Yes,
So
ma'am.
this part is
Yes.
actually that part over there. Does it make sense?
Yes, ma'am.
Yes.
Thank you. So now, let me show you how I crammed it when I was having problems in school. I didn't understand what was going on. Guys, make sure you combine your theory, especially from each chapter, so that it makes sense now. It shouldn't be like when I crammed and passed and forgot. So when you have y log of x base a, right? What you do is the bases will be the same. So your base will be a, and you say the base raised to y is equals to x. That's you change it. That's how you change it. Are we all together?
Yes, ma'am.
Yes,
The
ma'am.
base raised to y is equals to x. So now let's come in. Now they say solve each equation for x. Now look at a. A, they say we isolate. Those are isolated already. So this is equals to what? This is equals to a, right? Now, number 2, they said that, okay, let's go to number 2. Write the equation in an exponential form. Can someone help me to write this equation in exponential form? Guys, I need your help.
Ma'am, I think it's going to be e raised to the power of 8 is equals to x.
Why are you saying that? I don't want you to use the property, no? I don't want you to use the property that says e to the power of ln of x is equals to x. I don't want you to use that property. I want you to use the property where you change number 2, where you write the equation in an exponential form. How are you going to do that? Guys? Hello?
Yes, ma'am.
How are you going to do that? I'm giving you 30 seconds to discuss it. I don't want you to the property. I want you to use the, what's this? Where those steps where they say you change to the exponential form.
Can we
Guys, can I share with you how I did it? I don't know if it's allowed or not.
go ahead?
Okay. I said ln x is equals to, I wrote my 8 is 2 to the power of 3, right? And then I said 2 to the power
Ma'am wants
ln
us to,
x equal to 3.
are we doing the it in a, what do you call it? Exponential form. Ma'am wants the exponential form, isn't it? Not
Yes.
Yes.
solve. She just wants us to rewrite that. I'm only supposed to use the logarithm rule, like that one of the exponential. This one lean, isn't it lean same as log?
I thought that ln meant the base is e. That's what I said. E to the
Yes.
power of 8 is equals to x. So she said it's not right. So I don't know.
Yo.
Yeah,
Okay.
I
Katie,
thought
what is your version?
I don't know anymore. I told you, or at the second step, I said ln x is equals to 2 to the power of 3. And then I said 2 to the power ln x equal to 3. I'm not sure if I'm right or wrong there.
no.
Wait, let me write it down. Can you start, please? You said lean what?
X.
Ln x is equal to 2 to the power of 3.
Yes.
Mm-hmm.
After that,
And then, yeah, guys. And then I said 2 to the exponent ln x equal to 3.
two
Whoa,
to the
okay.
exponent.
Oh, I know, but I was somewhere. No.
Yeah, I know that, like, there I'm not right. So what did you guys come up with?
I think it will
If we say
yeah.
e to the power x is equals to 8, I
No.
think it's gonna be x is equals to e
What
to the
about
power 8.
what about these guys? Then we write lean e 8. So lean e is 1, must say 1 times 8. I don't know if it's making sense.
But
What I did, guys, what I did was, I just I reversed everything, right? So, it was log 2 open brackets 25 minus x is equals to 3, right? So I know that log 2, it's
Which
it's
step
it's
are
a
you
it's
doing?
Are we not discussing
We are
number
doing
1?
1, not 2.
Number 1.
oh, we're doing number 1. I thought you were doing.
So guys, on the right side, I think it's gonna be lean. It's gonna be e to the power 8.
yes, I still stand with that on my
E to the
part.
power 8. Then because if we put 8 back, I don't know. Wait. Which property must we use to raise it to 8 so that when you put it in the other side of on the left side of ln E, it's gonna be 1. It's gonna be 8 times 1. That's gonna just be 8. So I don't know how to write that, but yeah, that's the idea.
Come again.
You see, when we write, it's like, okay, so if you say e to the power of e to the power 8, we take that way, we take like the exponent, we times it with the base to get rid of the base. Where we say like 8, then it's gonna be ln E. So ln E is, we always know that ln E is 1, so we get the ln E cancels, then we're left with 8. So I don't know how to write that into a, what do you call it, exponential form.
Brenda, can you read the screen right now? I think
Oh,
ma'am is
okay. Yeah, yes. Okay. So now I was looking at my board.
um
Can I come in?
yes.
Yes,
I
ma'am.
think you guys discussing it really helps on you guys being directed. I know where to direct you now. I said to you, I don't want you to use the property. So meaning that, look at number 4. Do you see number 4, property number 4? It says, if you have e to the power of ln x is equals to x. Do you see that?
Yes.
Yes, ma'am.
Now, according to our note, it says that, where are we? It says that write the equation in an exponential form. I don't want you to do the all part where you raise the base to each side of the equation. I don't want you to do that part. So meaning that me now, I will do that part so that you don't do that part. So let me do it so that you don't do it. So meaning that we're using, because we know that the property that says ln to the power of e to the power of ln x is the same as just x. So meaning that we can raise the base to, as this says, or raise the base of each. Raise the base to each side of the equation. So let me raise the base so that you don't raise the base. So this is ln of x, then I raise the base, this is 8 to the power of 8. Right? Now we're saying that because this function is a one-to-one function. So that's why we are able to, it allows us to do this. Now, okay, because look at this. Because we know that e to the power of ln of x is equals to x, according to that property number 4 I showed you, meaning that on this side, x is equals to e to the power of what? E to the power of 8. Are we together?
Yes, ma'am.
Yes, ma'am.
Now, I want you to do the first part, which is this one. Me, I did this part. This part. And you need to do this part. There are 2 ways. It's this one and this, or this one. So write the equation in exponential form. 30 seconds. Let's discuss this. So how do we write in exponential form? Guys, let's think. Should I give you a clue?
Yes, please.
Yes, ma'am.
The definition of a common logarithm. The definition of a common log of x is what? What is the definition of a common log? Log of x is equals to? Guys, you said you wanted a clue. I'm giving you a clue, but I'm not giving you directly a clue. What is the definition of a common log? Log of x is the same as log what?
Log base 10.
Log x base 10.
Yes.
That's the clue. It might not be directly the clue, but that's the clue.
If that is the clue, I think I've already said it.
Which is?
ln of x is the same as ln of ex.
Ln.
Yes, ln e.
Like this.
Yes.
Which is not true.
No,
Because
base
this
e.
is equals to x. And ln doesn't have a base.
Oh.
Please help.
Okay.
She's saying the right thing, so please help. She's saying the right thing incorrectly. Please help. So you're saying ln of x is equals to what? Guys? Ln of x is equals to what? What is the definition of a natural log? Guys, what is the definition of a natural log? I'm not going to write it. Ln of x is what? Hello, can you hear me?
We hear you.
Yes, we
Ln of x is equals to what?
I think it's a ln of x.
Is equals to? Can you please make sure it's in your heart and in your mind?
Ex. Okay.
And this is
Yes.
section 4.3.
Log
This one.
x.
4.3. I'm sure we have covered this. 4.3. So, the reason why I'm saying that, some of you will end up doing this, and I might say which expression is correct and use this expression. We know that ln of x is the same as log of x base e. Are we all together?
Yes, ma'am.
So
Yes,
meaning
ma'am.
that we can come here and write log of x base e, isn't it? Is equals to 8. And we say that if we have y is equals to log of x base a, then we take a raised to the power of, we take a raised to the power of y, so it's a to the power of y should be equals to this, which is x. Meaning here, we take e raised to the power of y, which is e to the power of 8, which is equals to x. So therefore, x is equals to e to the power of y. Does it make sense?
Yes.
I need 3 yeses.
Yes.
So this is the first method, and this is the second one.
But ma'am, I think Lindy did say this.
Yeah, but I think she didn't mention the proper definition.
Oh. So you're
Yes.
looking for something specific because she constantly said it over and over again.
She was right. She was right, but then make sure you know all your properties properly. Your logs, that your ln of x is equals to log of x base e. Thank you, Lindy. Okay, now let me do this one fast. We said that we take the base raised to this should be equals to this. Isn't that what we said? So our base is 2 raised to 3 is equals to 25 minus x. And you know a is equals to b can be written as same as b is equals to a, meaning that I can interchange the position of this. So this is 25 minus x is equals to 2 to the power of 3. So this is 25 minus x is equals to 3 is equals to 8. So the minus x is equals to 8 minus 25. Okay, sorry, I'm writing answers in my, instead of what's here. Minus x is equals to, this must be minus 17, therefore minus divide by -1, divide by -1, x is equals to 17. Are we all okay on how I did number B?
Yes.
Yes, ma'am.
Yes,
No one
ma'am.
is lost.
No.
Okay.
No, ma'am.
Let's check the answers.
No.
So this is x is equals to e to the power of 8, therefore this. I think here they use the ln. We can also solve this problem another way. Okay, that is what they use there. e to the power. That is the property that, remember the property of raising to powers. Okay, we are right. Now, the first step is to rewrite the equation in exponential form. And that's what we did. And that's what we got. And that's what we got. Apparently, you can check the answers. If you want to check the answers, you can go back and say, okay, I found the value of x is equal to this, and go and substitute it into the original to check the answer. Now, they say logarithmic equations are used to determine the amount of light that reaches various depths in a lake. I know some of you hate these questions, guys, but you can't run away from them. I know you can't run away from them. You have to know them. The modeling ones, you have to know them, because you will definitely have 1 or 2 of such questions in the exam. Now, they say logarithmic equations are used to determine the amount of light that reaches various depths in a lake. This information helps biologists to determine the type of life a lake can support. Do you see that it's important? Why is it important to know all these equations and understand them? Because then if you continue working, especially in a scientific environment, you'll then be applying them. So as light passes through water or other transparent materials such as a glass or a plastic, some of the light is absorbed. Is that clear, guys?
Yes, ma'am.
Yes, ma'am.
So they say it is easier to see that the darker the water, the more light is observed. The exact relationship between light absorption and the distance light travels in a material is described in the next example. Now they say if I(O) and I denote the intensity of light before and after going through a material, and X is the distance in feet, the light travels in the material. Then according to the Beer-Lambert law, this is what we get, where K is a constant depending on the type of material. So here we're looking at the relationship of the intensity of the light as it passes through a material that is transparent, apparently. So they're saying that, for example, a material that is transparent, it's a window. So if light passes through a window, the intensity of light passes through a window, right? The light that you see on the other side of the window will be less intense compared to the one before it passes through the window. Does it make sense? It's an assumption I'm thinking. Guys?
Yes, ma'am.
Right. Do you think it's the same thing? If light passes through a transparent material, the intensity on the other side will be less than compared to before it passed through. Do you think it's true or it's not? My assumption, that's what I'm assuming happens.
I think it is true depending on the material.
Yeah. So let's see if mathematically that happens, if what we assumed happened. So they say where K is a constant depending on the type of material. Now they say solve for the equation for I. Okay, let's go back. This is what they want us to solve for. How do we solve that one, guys?
Sorry,
Can you
ma'am.
try it? Should I give it? Yes?
Your assumption, is it based on the, what do you call it? On that question that you were reading on the previous slide?
Yes, because they are saying that what's this? They are saying that, for example, here they're saying logarithmic equations are used in determining the amount of light that reaches the depth in the lake. Now, this information helps the biologists to determine the type of life a lake can support. Do you see that?
Okay, so on that last paragraph there, that big word, please don't use that kind of words. They'll confuse us in the exam. Apparently,
No,
oh, you can go ahead.
No, I won't use such words because sometimes I don't even know how to pronounce them myself, so I won't. No, so now, like they say, the more light is observed, the exact relationship between light absorption and the distance travel in the material is described in the next example. So now I'm just here, they're just showing how we are using the logarithmic equations that we're using, how to apply them in real life situations. So that's why I'm saying that if you're it's important that you understand your work, because if you understand your work, then it becomes easier to then apply them in your field, especially if you're going to take a science, engineering, and technology field in future. Because look at this. This information helps biologists to determine the type of life a lake can support by using logarithmic equations. Do you see that? So it helps them to actually check what life that particular lake can support. So now they're saying this is the equation that is being expressed, that they used. Now, the question is here, solve for I. How do you solve for I? So in I, for example, what they're saying is, for example, what they're saying is, let's say they give you K, which is a constant depending on the material, and they give you I0, which is the intensity of the light. What's this? The intensity of the light before it passes through the material. And they want you to find the intensity of the light after it passes the material. How are you going to solve for I? Because that's what they're looking for.
Ma'am, just to make sure it is 1 over K, right? It's not I, it's 1.
Yes, 1 over K. Okay, so let me let's write it here so that we can do it together. So this is minus 1 over K ln of I over I0. You know, my handwriting is bad. Let me copy it and see it again. Yes, it's that one. Let's copy it. So they want us to solve for I, guys. Make I the substitute of the formula. I'm giving you 1 minute so that you solve it. That's what they're saying. Solve for I. Let me paste that here. Okay, here. Solve for I. Coming back at 32. 1232.
Okay. Your screen name is
okay. They.
Okay, thank you. Okay, let's start, guys. I think you see that minus 1K, 1 over K there. We multiply both sides by the reciprocal. So we put K over 1. Then we multiply also on the other side. So it's going to cancel. So negative K over 1. Then when it comes, that is going to be minus KX. I don't know. First step, are we together? Or someone with a different approach?
I did that too.
We did that.
Oh, we multiply both sides by K over 1.
Yeah. Negative. Ne?
By 1.
Negative K
negative.
over 1, because negative and negative is going to make positive. Okay.
You divide, and when you go to the other side, it becomes the reciprocal. So K is multiplied by that X, and it equals to negative KX.
Okay, now we are left with ln of, is it 1 or L? Okay, 1 over 1, 0. I don't know. Is it 1 or L, guys?
It's
I.
L.
I.
L. I.
Okay, I. Okay, so
I.
how do you get of the ln inside?
It's ln. Okay, I
How do you
over.
get rid of the ln to put it on the other side?
Was in the bracket there, I said 1 over I0 multiplied by I inside the bracket to break that equation up. So I have 1 over I, and then I have multiplied by I. We agree?
I know, because remember we want to make I the subject of the formula.
Subject of the formula.
The one on top, the way marked. So we need to get rid of this. Before we touch the bracket, we need to remove the lien outside.
I did not think I was thinking about the property. So you know how the properties, if you multiply it, you can add them together. So that's why I separated ln and IO and from I. So that if that happens, I'm going to get the ln of 1 over I0 plus the ln of I. Do you feel me?
Okay, yeah, you use law number 3, number 2, something like
Law
that.
1. Law says if you have ln of A multiplied by B,
So
you can separate it A plus ln of B. Am I right?
you are breaking up, so I didn't hear the other part.
I'm breaking the I over 1 over 0, I0, that thing.
Yes. Mhm.
So that two
So it's gonna be
numbers.
lni minus ln I base 0. That's what you say.
My,
I
ln
have
of I minus ln of what?
Guys, listen. We have a law. It says if you have ln of A multiplied by B, it is equals to ln of A plus ln of B. Okay? Am
Yes,
I
but
wrong?
this is division. Karo. Yeah, we are understanding.
Yes.
So here is subtraction. We are following.
Yes.
This we use subtraction. Yeah,
Yeah, this
because
is
it's division
because
here.
division.
We use the law number 2.
What? No. Am I? What am I doing? Oh, I
Multiplication is addition, division is subtraction.
You
So
should. This is a division.
okay.
And
My
for division we use minus.
Yes. Okay. If you were saying I over A, I get you now. What I was doing, I was setting them to be multiplication so I can add them. So what you did was take them complete. Okay, let's do the second one. I get it now. I didn't get the confusion. Sorry, guys. So
Sorry, guys. Is lim x is equals to log base ex. Can I apply it here also?
Which one?
That one of lim x is equals to log base ex. Can I apply it here? Instead of x, can I put I over IO?
come again.
There's a law. It says lim x is equals to log base ex. Can I, instead of x, can I put I over IO?
Instead of X.
Okay, I think we must divide by lin. Yeah?
By lin.
Yeah,
Yes.
because I'm now confused. Let's do the approach of dividing. So we are there at lin. I don't know, maybe try to show us something.
On my part,
divide there, we're gonna have like sort of an inverse where we're gonna have lin. So lin basically is E, right?
Yes.
So if that one, we're gonna divide there, we're gonna have 1 over E to the power K X. I don't know. So that's 1 over lin.
Can I come in?
Yes, ma'am.
Yes, ma'am.
Look at number 4.
Yes.
Yes, ma'am.
So look at this part over here. Number 4, what does number 4 say? I mean, let's go back to number 4. It says e to the power of ln x is equals to x. So meaning e to the power of, e to the power of ln of x is equals to x. I'm coming in. I don't even know where you guys were. Yeah, ne? Okay, so the first part. Let's start with the first part before I explain. What did you? What was there?
Can Sakane, can you mute, please?
Okay, where did you get up to before you talking about the ln? You did what?
We multiply by the reciprocal of minus 1 over k both sides. So we're left with the ln I over I base 0 is equals to minus kx.
Okay, so you multiply by minus k over 1 both side.
Yes.
So that you can then, what's this? So this becomes k over k. This k cancels that k. Okay, let me not explain like that. So this k cancels that k, this negative cancels that negative. So you left with ln of I over I0 is equals to minus xk. That's what you're saying.
Yes, ma'am.
Yes.
Now you could have used this ln because remember log is a one-to-one function. So you can say e to the power of ln of I over I0 is equals to e to the power of negative xk. And then according to this one, as soon as you raise to the power, then you're only left with x, meaning you're only left with I over I0 is equals to e minus xk. So then you know that your I over I0 is equals to e minus xk. So then I is equals to I0 e to the power of negative xk. Where did you guys go wrong?
We were going wrong on other one. They wanted to rewrite that one.
Ma'am, I got it.
Well done.
I
Yeah, I
got it,
think
but I used this one of
different method.
ln x is equals to log base ex.
Okay, wait. Let's start with, I think Brenda is the one talking, and then I come back to you. What's your name, guys? I can't see your names. The one who got it.
Me,
The one who got it. What's your name? May.
Antonia.
Okay, I'll come back to you. I just want to. I want to see the confusion that you guys had. What was the confusion?
So
You
the
wanted
confusion
to?
was otherwise we're supposed to separate that ln I minus ln 0.
Okay, let's
So,
see.
or
So you
divide.
wanted to do that. You said ln of I minus ln 0.
Yeah, so that's where we were arguing there, discussing there. Or we end up saying like let's divide with the reciprocal of ln. So ln, I think ln is same as e. So if you divide with 1 over e, then it becomes the reciprocal. On the other side, you still have 1 over e to the power kx, and then you are left with 1 over, sorry, I over I0. Then you multiply both sides by I over 0 to be left with. It still come to the back to the same thing though, to the same answer you got there.
I think
But
I'll need it.
In the class we were there, we were ln I minus ln I0.
I think let's avoid to have more steps. Because from here, you were supposed to be able to say but then if you raise ln to e to the power of ln of something, let's say a, this something will always just be equal to something because e and that, they do not cancel, but then because of a property, they disappear. And you're left with inside. So if you see a ln here, then you can say e to the power of ln. If you see an e to the power of x, you can then put a ln of x so that you only have x. So let's try to avoid having long steps. If you understand it like that, it's fine. But let's try not to have long steps. Are we all together?
Yes, ma'am.
Yes, ma'am.
May, can you please send me the picture so that I can see how you got it? so that we move forward, because I notice we are a bit behind. Okay. So we then have, okay, now, so we got that I is equals to E minus K. Is it K? What did we get, guys? Minus XK. I0 minus XK. Now they're telling us K is equals to 0,025, and they're telling I0 is equals to 14, and the depth, which is X, is equals to 20. So they just want you to substitute here, which is 14 e to the power of negative 0,025 times 20. That's what they want you to do for number B. Are we all together?
Yes,
Guys?
Yes.
Now for
Yes, ma'am.
the exam, you see, like, for example, here it might not be easy to simplify. Then I will leave it like that. This might be another option. Are we all together? So if you're unable to simplify it, I mean, not simplify, to put into the, to substitute, that's what matters. You understand your work and be able to substitute. So let's see. This is exactly what we got. Exactly what we got. So the light intensity at the depth of 20 is about 8.5. Which is lower than initially how the light intensity was before, because it was 14 before and 8.5. So our assumption was correct that a light, as it passes through a material, a transparent material, the light intensity actually decreases. Let's look at compound interest, guys. Now they say, in principle, P is invested at an interest rate of R for a period of T years. Then the amount A of an investment is given by, remember the simple interest. We talked about the simple interest formula, right? Guys? Are you
Yes,
still there, or am I talking to myself?
Yes,
Okay.
ma'am.
we are
And
here.
then there was a compound interest formula. And then there was a compounded continuously formula. Right? Now, if we go back to grade 10, when we were looking for T, how did we solve that? Given A, P, R, N, and we're looking for T. How did we solve that? If you remember very well in grade 12. Or you don't remember? Guys?
So remember, what are we solving for?
I forgot.
I'm saying that if you are given A, you are given P, you are given N and R. So this is N. How did you find T? Or you forgot?
Yes,
We take the logarithm, I think, the natural log.
Not the natural log, but the logarithm. The common log.
The common log.
So they say, yes, thank you. So we can use the logarithm to determine the time it takes for a principal to increase to a given amount. Now remember, how do we remove, this is a compound interest, and this is also a compound interest, but this is a continuous compound interest. So don't, this is compounded continuously. So don't make a mistake in the exam if I ask you a question and then you give me a compounded continuously formula. What happened to get here is that we said that this part over here actually turns to E. And we did mention that in the previous, I think it's 4.3. Let me go to 4.3 and see. Is it 4.3? The natural log, there we go. I think it's here, where we showed that this part of the compound interest actually approaches. Okay. No, it's not 4.3. Then where is it? Okay, I'll go look at it, but I know I explained this part. That the part of the compound interest, this part actually approaches E, then it ends up here to where you get E to the power of RT. Now they say we can use the logarithm to determine the time it takes for the principal to increase to a given amount. So now they say a sum is invested at an interest rate of R is equals to 5% per year. Find the time required for the money to double if the interest is compounded according to the following. How many minutes should I give you to try it? Yay, what am I doing? How many minutes should I give you to try it? I know you. How many minutes, guys, should I give you to try it? Let me hide the solutions. Hide. I want you to hide the solution. How many minutes should I give you to try this question? They say that find T for the money to double if the interest is compounded according to the following methods. How many minutes?
5.
Okay. Let's come back at 12:55.
Let's go on.
Guys, which formula are we using?
The first one we use the normal one for A. T is equals to P brackets 1 plus R over N to the power N. And the
Oh,
continuous one, we're going to use PERT to the power sum.
Let's write individually.
We can talk here also. I just see people, they're quiet. Okay, so on the right side for the formula, the accumulated is going to be 10,000, eh? Because they say it's double, so we multiply 5,000 times 2.
Yes.
So there's going to be 10,000 is equals to the principal is 5,000, parenthesis 1 plus 5% over 4. Sorry, how is it 2? Ne?
Same here is true.
5% over 2.
Over 2. Then we raise that to 2t.
Yes, we raised the 2t.
Then we divide both sides by 5,000. We get 2 equals to 1 plus
1.
am I still in?
I also think the percentage, the 5%, you need to convert it to 0.05.
Can you guys hear me? I'm not sure if I'm still in the
Yes.
call.
No,
And
Thank you.
after converting 5%, we divide it by 2.
yes, because our n is 2, yes.
So now we have 2 is equals to what? 1.0125 to the power 2t. Where 2 from here? I think that's why we take the log, né? The log, common log.
Not both sides. We're gonna say that exponent, which is 2n. So we say 2n is equals to the log of the base, which is 1,025 and 2. So it's gonna be log 2 base 1,
Said not both sides.
025.
Pardon?
I'm saying that I don't think we're gonna introduce the logs both sides. So I think we're gonna say that exponent, which is 2n, is equals to the log 2 base 1,025.
What?
Ah?
Yeah,
You have to say log 2 is equals to log on the other side. You cannot just have log on one side.
Yeah, I think we need to
On
put the
the
log
right
on
side,
both
you must
sides.
do on the left side. There.
Both
Okay,
sides.
Mm.
okay, so Mina, let me tell you how I did it. Okay. I used
If you do log for both sides, remember you still have 2t. We are solving for 2t, so it's gonna be log 2 is equals to log 1.025 to the power 2t. Then you have to put the 2t on the other side. The left side where it says 2t, isn't it? Because you cannot just say you have to take log for one side.
I think I must explain what she's doing so we can help her properly.
Yeah.
let me tell you what I did. Okay.
Okay.
So I used the methods that we used like grade 12, you know. So I said I get it. I used the original formula, né? And then I said 10,000 divided by 5,000, right? So we divided by 5,000 both sides, right? And then we're left with 2 is equals to if we add that bracket 1 plus 5% divided by 2, it's gonna give us 1,025, right? Do you
Right.
guys get what I'm saying?
Yes.
Yes, up to so far we can.
Yes, so I'm gonna say 2 is equals to 1,025 to the exponent 2n, right? And
Yeah.
then that's where I introduce my log. So I'm gonna say that 2n, which is my exponent, I'm gonna, I don't know how to explain it, but I said 2n is equals to the log of 2 1 to the base of 1,025. So my base remains my base, and then I take that 2 from that side to the, I make it my exponent. And then I divided by, I was left with 2n is equals to 28,071. And then I divided by 2 both sides to get the n. I got my n to 14 years. I don't know how you guys did it or approached it.
No, I think where you introduced the log is where we lost each other. Your
Yes.
to introduce the log on both sides. Because you just didn't put a number. But let me ask, according to which law of logs or of natural logs did you use to do that? Maybe that's why we're not getting them.
Okay. After
Can
you
I come
divided,
in?
just wait, ma'am. After you
Okay.
divided by 5,000, okay, where you get 2 on the other side, right? On the bracket there, what did you get?
My bracket, like the total of my bracket is 1,025.
1,025, right? And you still
Yes,
have
to
to
the
the power
exponent.
2t.
Yes.
So this is where
Yes,
you introduce your log, right?
right.
How did you introduce it? What law did you apply here?
I
Your
don't
answer is
know what the
correct.
laws
Your
is
answer is
called, but
correct.
it's the laws of Hatiking.
Ex-
Yeah.
Okay, what law did you apply?
I'm saying, I
Mm,
said that my base remains my base, right?
yes,
So I
one
said
odd.
the log of 2, the
Uh,
base of 1,025. That's what I said.
okay.
So I'm left with 2n is equals to the log of 2 base of
Got log of 2.
1,025.
You are
I'm
cutting.
sorry. I said.
Did you
Okay.
introduce the log?
No, I did not introduce the log both sides. Emma, you know what?
Which
I
property did
don't
you?
know.
Can I come in now?
Yes, ma'am, you can come in
Okay, ma'am,
because you're
please come
breaking
in.
up.
Yes,
Yeah.
Yeah.
Okay, so this is what I think we started with in high school, right? The formula first, because then we know that it is they're saying they compounded something, right? What was the question? Semi-annually. So we started with this formula, and then because we were looking for, we divided up by p so that this p cancels this, so that we have this right hand side value, right? Now we then took log so that this term can be multiplied here. We took the log both sides. And then we ended up with that particular term there. And then we simplified and we found that t is equals to, so this is more of like a general term of how to find this particular t value. Now, if we go back to our question, by not looking at that, we're saying that they say it's compounded semi-annually, meaning that we're looking at a of t is equals to p of 1 plus r over n to the power of nt. So you found that your p is 5,000 rand. And then your a is equals to 10,000 rand. Where do we get this 10,000? We get this 10,000 because they said the amount doubles, right? After that period. So meaning that it comes 2 times the initial amount. And then we know that r is equals to 0.05. And we know that n is equals to what? N is equals to 2 because it's semi-annuals. How many semis are in 1 year? There are 2. Okay? Now, we then go and substitute and say this is equals to 10,000. How do you write 10,000? Okay, equals to 5,000. 1 plus 0.05 over 2 to the power of what? To the power of 2 times t. Now, as I said, I do not want you to simplify that because you will not be using a calculator. So, because we are looking for t, I can divide by 5,000. I can start there. Divide by 5,000 both sides. And if you divide by 5,000, that 5,000 cancels that. So then here we have what? This is 2. Is equals to 1 plus 0.05 over 2 to the power of 2t, right? Then, now, because now I see t is in the power, and I want to remove it in the power so that I can simplify it, then I introduce the log both sides. 1 plus 0.05 over 2 2t. And if we use the log law, we know that the power has to come in front of that. So this becomes log of 2 is equals to 2 times t log of 1 plus 0.05 over 2. Now, let's write it here. Log of 2 is equals to 2t log of 1 plus 0.05 over 2. Remember, I said A is equals to B and B is equals to A. So I just want to take this on the other side and this on the other side. So meaning that I can write 2t log of 1 plus 0.05 over 2 is equals to log of 2. So then I can divide by this log. 2 log 1 plus 0.05 over 2 over 2 log of 1 plus 0.05 over 2. Therefore, t is equals to log of 2 over 2 log of 1 plus 0.05 over 2. Do you see how I found my t without using a calculator?
Yes, ma'am.
So this is the same as what I've derived here. So this is the formula. So in the exam, I might say find the value of t, and I don't give you p and whatever. So then it means you have to use this formula here. If we simplify, you'll see this is just log of 2 over 2 log of what? 1 plus 0.05 over 2. That's what we got. But then the formula becomes this one over here. So you can just substitute your A, your P, your R and your N here. And I've derived this. While you were talking, I've derived this. Please go and check. If you don't understand it, I can explain it next week. Make sure you know how to use this formula and derive it. Are we okay?
Yeah, we are okay, but
Yes, ma'am.
we were lost about I don't know, was it Matabo's way of doing it without taking log of both sides? That's where we were confused about, but that's where we understood it.
Oh, okay.
It's Bunche. Ma'am, can I say something?
Yes.
So when I substitute everything that we were given there by your formula, I get 14 years. And when I substitute also in the way that I did it, I get 14 years as well. So I don't know maybe I don't know how to explain it, how I did it, but I got the same answer.
You see my issue.
Okay.
Yes?
What you using calculator, Mus?
What did you use? What did you use? What way did you use?
Ma'am, I'm not so very good with explaining, but I didn't introduce logs both sides. I only introduced the log on the right. So then
remember mathematically, grade 3, we didn't even know what we were singing. What you do on your left, you also do on your right. So if you only did it on the left, then it might not be correct. Okay, let's look at this. What is 8 divided by 4?
It's 2, ma'am.
What is 4 divided by 2?
It's 2, ma'am.
It's 2. So we get the same answer. Now, at some point, you might be lucky that whatever mistake you have, then you get the answer. But if you introduce the log only on one side and not on the other side, then that's a problem. You might have gotten the right answer, but your method might be wrong. So meaning that for another example, it might not work. If you choose a different example, it might not work. So otherwise you can take a picture and then send it on the chat. I'll look at it while we look at the other work.
Okay, ma'am.
If I'm asked, did you use a calculator, Bontle?
Yes, I did use a calculator.
Okay, so here's what she did, ma'am. She said 2t log of base 1.02 of 2.
Oh, I see.
Then she divided by 2. Okay,
Oh,
now
I see.
Yeah, that's what she did.
Yes, that's
You
what I
see,
did.
you see, that's why I'm saying to you, please calculate this, because I'm training not to use a calculator, because in the other modules I'm using a calculator. So when I teach here, I try not to use a calculator, because you are also not going to use calculators. That's why I was able to derive this and then take you here, basically.
Okay, ma'am. No chat. Thank you.
Thank you. You're welcome. Now continuously. Continuously, what is the formula for continuously? Let's look at that one. So they want us to find t given, what's this? Now we are using a continuous formula. A of t is equals to P of E R T, right? Now we know that A is 10,000. And we know P is 5,000. And we know R is 0.05 times T. So we are looking for T, right? So here we divide by 5,000. Here we divide by 5,000. And then we end up with 2 is equals to e to the power of 0.05 t. Now my issue is, I like saying a equals to b, therefore b is equals to a. I just like doing this, meaning that I like writing whatever I need on the left hand side. 5t is equals to a. Here, since I have, remember what I said, if you want to remove the e, what do? Guys, if you want to remove the e and you want to solve for the power of e, what do?
I think we said we raise it to the power of e.
You introduce the ln.
Thank you. If you have e to the power of x,
ln
we introduce the ln. If you have what's this, ln of x, then take ln to the power of x. So meaning here we have e, so we introduce the ln. So this is ln of e to the power of 0.05t, which is ln of 2. Now this is equal to 0.05t is equals to ln of 2. Therefore, t is equals to ln of 2 divided by 0.05. And I'll leave it like this in the exam because it's multiple choice and you're not allowed to use calculator. Do you see that?
Yes, ma'am.
Ma'am, yes, ma'am.
Okay. Are we all together there?
Yes, ma'am.
Yes.
Okay, so let's
Yes.
see how we did the performance. Yes. So they use the calculator. So this is where you will end, but not with a 0.15 there. No. Just the way I ended. So the answer is correct. This is the answer. So this is where you end in the exam because you will not be using a calculator. So this is where they use a calculator to check the approximation. So the money will double in 13 years. Are we all together? Okay.
Yes, ma'am.
Yes, ma'am.
Yes.
Oh, we are done with this section, thank God. Any question? Any question? Guys? Any
No,
question?
On my side, no, ma'am.
Okay, so now this is what should I give you 5 minutes? You go in and drink water and come back, or you are tired? Guys?
No, you can come back.
Okay, so maybe we can stop the recording, this recording, and start a new one.
Okay, ma'am.
Yes, so this was 4.5. Let me stop it so that for the new section, we start a new one. Okay, now go breathe in